Welcome to Junior High School Math Series. This time, let us discuss the slope of a line. Let us start with the definition of a slope of the line. The slope of a line is the ratio of the change in the y-coordinates to the corresponding change in the x-coordinates of any 2 points on a line. The slope is also called the gradient of a line. The letter M is commonly used for the slope, but the reason is not known, and the choice may have been arbitrary. Mathematician John Conway has suggested M could stand for modulus of slope. A high school textbook in algebra states that the reason for M is unknown, but remarks that it is interesting that the French word for took line is monter. Math historian Howard Eve suggests it just happened. This is from services.math.duke.edu. Let us have some example. In here, we are given the graph of lines and 2 points are chosen. We have 0, 2 and 7, 4. From the definition of the slope of a line, it is the ratio between the change in y-coordinates and the corresponding change in x-coordinates of any 2 points on the line. From 0, 2 to 7, 4, we can see that the change in y-coordinates is 2 units. From 0, 2 to 7, 4, also, we can see that the change in x-coordinates is 7 units. Hence, the slope M of this given line is the ratio between the change in y-coordinates over the change in x-coordinates, and that is equal to 7 over 2. Let us have another example. A line and 2 points chosen. We have 0, 4 and 8, 1. Observing the changes in y-coordinates and x-coordinates of these 2 points, from 0, 4 to 8, 1, the y-coordinates change from 4 to 1, then the change in y is negative 3. Also, from 0, 4 to 8, 1, we have the change in x-coordinates as equal to 8 units. Hence, the slope of this line is equal to negative 3 over 8. This time, let us have a horizontal line with 2 points at 0, 2 and 8, 2. Notice that there is no change in y-coordinates. But for x-coordinates, from 0, 2 to 8, 2, we have change in x-coordinates as equal to 8 units. Hence, the slope of this line is equal to 0, having no change in y-coordinates, over 8, or simply, the slope is equal to 0. Next, let us have a vertical line with the points 6, 0 and 6, 5. Observing the change in y-coordinates from 6, 0 to 6, 5 is equal to 5 units, while there is no change in x-coordinates since there is no movement on the x-axis. Hence, the slope of this line is equal to 5 over 0 since there is no change in the x-coordinates. Therefore, for this line, the slope is undefined. This time, let us have the formula for determining the slope of a line. Let the ordered pairs x sub 1, y sub 1, and x sub 2, y sub 2 be the coordinates of 2 points on a line. Then the slope M can be found as follows. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. For the slope to be defined, x sub 1 is not equal to x sub 2. When x sub 1 is equal to x sub 2, the slope of the line is undefined. Let us have some example. Find the slope of the line containing each pair of points. Letter A, negative 3, 5, and 2, 9. Letter B, 5, negative 2, and 6, negative 7. Letter C, 5, negative 11, and 5, 12. Letter D, 15, negative 8, and 17, negative 8. Let us begin with letter A. From the formula, m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Given the 2 points, for us to be able to solve for the slope, we can identify which point represents x sub 1, y sub 1, and which point represents x sub 2, y sub 2. Let us label the first ordered pair as x sub 1, y sub 1, and the second ordered pair as x sub 2, y sub 2. Now we can solve for the slope by substituting x sub 1 equals negative 3, y sub 1 equals 5, x sub 2 equals 2, and y sub 2 equals 9 to the formula. Hence we have 9 minus 5 over 2 minus negative 3. 9 minus 5 is equal to 4. 2 minus negative 3 is equal to 5. The slope of the line is equal to 4/5. Next, let us have letter B. 5, negative 2, and 6, negative 7. It doesn't matter which point we choose to represent x sub 1, y sub 1, or x sub 2, y sub 2. This time, let us have 6, negative 7 as x sub 1, y sub 1, and 5, negative 2 as x sub 2, y sub 2. Solving for the slope, we have y sub 2 minus y sub 1, then we have negative 2 minus negative 7 over x sub 2 minus x sub 1, that is equal to 5 minus 6. Negative 2 minus negative 7 is negative 2 plus 7. 5 minus 6 is negative 1. Then we have the slope. Negative 2 plus 7 is positive 5 over negative 1. Then the slope of this line containing 5, negative 2, and 6, negative 7 is negative 5. Let us have letter C, 5, negative 11, and 5, 12. Let us use 5, negative 11 as x sub 1, y sub 1, and 5, 12 as x sub 2, y sub 2. Substituting the values to the formula for the slope of the line, we have m is equal to y sub 2 minus y sub 1, so we have 12 minus negative 11 over 5 minus 5. Notice that the x-coordinates of the 2 points are equal. Hence, in the numerator, we have 12 minus negative 11, that is 23. 5 minus 5 in the denominator, that is 0. So in here, the slope is undefined. Let us have letter D, 15, negative 8, and 17, negative 8. Let us have x sub 1, y sub 1 as 15, negative 8, and x sub 2, y sub 2 as 17, negative 8. Notice that the y-coordinates of these 2 points are the same. Substituting to the formula for the slope, we have negative 8 minus negative 8 over 17 minus 15. In the numerator, we have 0. Denominator is 2. Then the slope for this line is equal to 0. In the next set of examples, the slope of the line is given and a coordinate of one of the 2 points is unknown. Letter A, 3, negative 5, and 2n. M is equal to 2/3. Let us have 3, negative 5 as our x sub 1, y sub 1, and 2n as our x sub 2, y sub 2. Substituting the values to the formula for slope, m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, we have 2/3 is equal to n minus negative 5 over 2 minus 3. So we have 2 over 3, n minus negative 5 is n plus 5, 2 minus 3 is negative 1. Multiplying both sides of this equation by negative 1, we have n plus 5 is equal to negative 2/3. Subtracting 5 from both sides of this equation, we have n is equal to negative 2/3 minus 5. Negative 2/3 minus 5 is negative 5 and 2/3, so we have negative 17 over 3. Next, letter B, n negative 17 and negative 4 negative 20. M is equal to negative 3/4. Let us have n negative 17 as our x sub 1, y sub 1, and negative 4 negative 20 as our x sub 2, y sub 2. Again, substituting the values to the formula for slope, we have negative 3/4 is equal to negative 20 minus negative 17 over negative 4 minus n. Multiplying both sides of this equation by 4 times negative 4 minus n. On the left hand side, we have 12 plus 3n. On the right hand side, we have negative 20 minus negative 17 is negative 3 times 4, that is negative 12. Subtracting 12 from both sides of this equation, we have 3n is equal to negative 24. Dividing both sides by 3, we have n is equal to negative 8. The following illustration summarizes the 4 possibilities for the slope of the line. When the graph of the line increases from left going to the right, the slope of the line is positive. When the graph of the line decreases from left going to the right, the slope of the line is negative. When the graph of the line is a horizontal line, the slope of the line is 0. When the graph of the line is a vertical line, which means there is no movement on the x-axis, the slope of the line is undefined. The slope of a line does not only tell you whether the line rises, falls, or is horizontal. It also tells you the steepness of the line. For two lines with positive slopes, the line with the greater slope is steeper. Let m1 be the slope of this line 1 and m2 be the slope of this line 2. Since line 1 is steeper than line 2, then the slope of line 1 is greater than the slope of line 2. For two lines with negative slope, the line with a slope of greater absolute value is steeper. In here, let m sub 1 be the slope of this first line and m sub 2 be the slope of the second line. Since the second line is steeper than the first line, then the absolute value of slope 2 or m2 is greater than the absolute value of the slope of line 1 or m1. That will be all. Thank you for watching. Please subscribe for more math lessons.